Hi, this is Mark Kemper with EMS, and today's video we're going to talk about how to design safety guards and other safety equipment for machinery that you would find in a shop. So we're out here at Elevation DF in Tampa, Florida, and we're going to 3D scan some various equipment in their shop and show how we can design guards, fences, and other safety equipment for different types of machinery you would find in a shop. Because there's companies out there that will go into a factory or a shop and they will hand measure and take photographs of everything in the shop so that they can design safety equipment for that machinery. Well, that process is prone to mistakes, and if you're traveling out to them and taking measurements, if you miss a measurement and you don't have it, then you're guessing, and there's a lot of rework. They'll build stuff back at their place, take it out to install it on a machine, and it doesn't fit. So we're going to show how you can do 3D scanning, take that digital data, and design fences, guards, and other safety equipment that fits very accurately and it fits the first time. So we'll do some 3D scanning, we'll take that into software, and we'll design all of our safety equipment to fit onto that machine perfectly.
All right, so to get started, we're going to discuss the different scanners we're going to use in this video, because we're actually going to use a couple different 3D scanning technologies. The first one you see here is what's called a hemispherical scanner. This is specifically made by a company called Surphaser. This is a very high resolution, high accuracy scanner. And essentially what it does is it spins around. There's a mirror rotating in there, mirror in the housings on a 45. A laser beam is shot out, redirected off of that mirror, and sends out a single point, but it's rotating in two directions. So the mirror itself, you can see, is rotating, and then the whole body slowly rotates. So essentially what it's doing is it's firing out one point at a time, but in two directions, and it's, sweeping around. That's why it's called hemispherical. And basically you get a 360-degree scan in the one orientation, and you get 270 in the other. The 270 is because the base or the bottom of the scanner obviously is being blocked. But basically what this does is it fires out a point, and it measures the return back to the scanner and records the distance. So it's kind of just like it's individual points, but it's over 1 million at a time as it moves around. So the advantage of this scanner is it'll go a long distance. It'll go, depending on the configuration, there's different ones. It'll go hundreds of feet. This is the medium range, which is good to about 70 feet. So when we're doing something large, this is a great scanner. Now it's line of sight like most scanners, so you got to move it into position. Take a scan and then move it again. So for this waterjet, we'll take 2, maybe 3 scans to get around it for what we need. But we basically just place it there, tell it to scan, let it do its thing, and then we'll look at the data here later. But you basically take those scans and merge them and put them all together. So when we're doing larger things, it makes sense to use a machine like this or a scanner like this. And again, this is called a hemispherical 3D scanner. All right, so let's go ahead and take a look at the 3D scan data from the Surphaser. Now, while we were scanning the waterjet, we went ahead and moved the Surphaser around the shop and took a few more scans, just did some 360-degree scans of the whole shop. Now, we're here in Design X from Geomagic, which is a really powerful software tool for reverse engineering, because the problem is trying to load in. This model had like 80 million triangles. Now, we decimated it down, see where we're at now, to about 23 million. Just basically reduce the size without reducing the accuracy and the definition of everything. And then I also cut the roof off just so it's easier to see inside. But we moved around and took a few more scans. And what's nice about that is, again, we've digitally archived everything. We have it here for maybe later uses. For example, over here they're building storage up above. and it's not complete yet, but let's say we're going to want a railing up there. Of course, you could go hand measure it, or in Design X, we can come right in here and, we can pick this wall and let's say pick this edge here and, get a dimension. So we can go around, we can analyze a facility. Maybe, we've got some storage racks here. Maybe they need to be fenced off, we could come in and measure, some different things here. So how far is it from, let's say, here to here? So you could literally analyze a whole shop digitally just by, looking at the scan data. And we only took about 4 scans. We took one here and one here. We could have taken even more, but you get the idea. Now, of course, it's all line of sight, so there were some things in the way in certain spots. But the point is you could scan an entire shop and, look at this file digitally and determine, where maybe other safety equipment might be needed. Okay, so now let's go ahead and look specifically at our waterjet cutter. And you can see I've already designed one safety fence here along the front of the machine, because this head here moves up and down. And if we want to keep people out of the path of it while it's running, we could design a fence, something like this. And this fence could be designed to swing down or swing open to load materials. But it could even have a safety switch that while, the machine won't run if this door or this fence is open. Now, one of the things we can do that's pretty neat is we can separate scan data. So what I did, for example, is I separated the head from the machine, and that will allow me to basically move it around. So I'll just select it here and grab it, and I can just move it. So I can check for clearances, even just with scan data. This isn't CAD data. This is just raw scan data, but I can still easily separate different pieces of it. And we do that just by windowing in. We've got all these different selection tools. Let's say, for example, this here, I could grab it, select it, and then separate it into its own file. Okay. So I'm going to get rid of that, or not do that because I don't really need it. But you can see we've designed this fence. We've mounted it up right on these support structures of the machine, which are very sturdy. But let's go ahead and design something else, because that was pretty straightforward. Let's say we've got this box here. Let's say it's an electrical box, or maybe a high pressure water manifold box or something. But basically, we don't want people having access to it. Now we've got a water hose sitting here, just like a garden hose. We'll just ignore that because that obviously could be moved. But we want to design something, and a little bit of a challenge here is, you see, it's kind of underneath the structure of the machine here a little bit. So how do we build a guard box around that? So let's kind of walk through that in a little more detail. So what I've done is I've set up a plane, a reference plane, which would represent the front of the box, and that's just a plane that you can create and offset in the software. And then I'm going to come under here and I'm going to say, let's do a mesh sketch, and it'll be this part of the machine, and I'm going to pick that plane. And you can see what it's done. This kind of teal colored line is a reference sketch through the scan data, so I could pick where I want it. Okay, now I'm going to leave it right at that plane because that's where I want it, and I'm going to hit OK. Okay, and let's rotate this, just easier to see here. Okay, and let's hide our fence, and I've kind of grouped some of this stuff. Let's hide the surface. Okay, so you can see here's our reference sketch on the machine. Now, you can see where it goes underneath. We didn't get data up under there, but that's okay. I've got enough information here to kind of determine that. But what I'm going to do with that reference sketch now is I'm going to build a real sketch, real CAD geometry, because right now this is just visual. It's not real geometry, so to speak. So I'm going to come in here. I'll use the line tool, for example, and I'm going to come in and I'm just going to draw a line, and then I'm going to approximate where the bottom of the machine is right there. Now we'll trim all this up here in a minute. Typically when you work with scan data, it's better not to try to draw in the corners on the scan data. You'll see here. Now I'm going to turn the mesh back on because I need to see where the bottom of the box is. Plus I want a little bit of clearance. Plus maybe there's going to need to be an opening for those wires or hoses. So let's go down to about right here. I'll come out perpendicular here. And you can drive this all by dimensions. I'm just going to hand draw it for our exercise, but you can come in and add dimensions and make sure everything is parallel and perpendicular and those kind of things. So for example, here I'll make sure that that's these are all parallel and perpendicular. So there's my basic shape. Let's turn off our mesh, and now we'll trim it back up, or trim it all up. So then we just come to the trim command. We'll do corner trim, 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 trim. Okay, so there we go. So there's our first kind of outline, and let's take a look at our scan data. Okay, so there's that basic shape. Now we're going to want this as some kind of tube stocks. So let's hide that again. And so we'll do an offset, and let's make it, I don't know, maybe 1 inch for this. That all can be determined. We're going to offset it in, and there we go. Now, you could break this all up to represent the individual pieces of tube stock, whether you're going to, cut them on 45s and weld it all together. For this exercise, I'm just going to make it all one, just to keep things simple. Okay. And so there we go. Let's bring back our mesh. Okay. So there's our first one. Now let's give it some thickness and turn it into, there's our sketch, right? And with our mesh, so we can see everything. And let's give it some thickness. And we'll make this one as well. And let's go the other direction. And now it'll become a solid body. Okay. So you can see now we can come in and look. Yeah, we got enough clearance there. If not, we can obviously make those changes. But you can see I can make this and it mounts right up to the machine. Now what I'm going to do is I'm going to come in and make a copy of it. So in our model, we're going to go to transform body. We're going to pick it. We're going to duplicate it. And let's go here. Come in. And let's start moving it over. And let's approximate the same clearance. But then we can come over here and give it an exact value. So let's say -22. There we go. And there is our second one. And again, we're going to ignore this hose that can be moved. That's a rag laying up there. There's some other equipment. So, it probably helps to have a nice clean work environment. So now let's connect it with some cross members. And to do that, we'll just hit the sketch. We don't need a mesh sketch this time. We're just going to do a regular sketch and just pick one of these inside faces. Doesn't really matter which one. Let's go back here and let's hide our mesh. Okay. And so let's say, for example, so we'll just use the rectangle command and we're going to put one corner there, one corner there, one corner here. And then because this is all kind of under the machine, I think we're going to just want to do one up here. Let's take a look. And again, that's the beauty of having this scan data. Yeah, so we really can't put one here. You'd go right through the machine. Okay, so we've got those now. Now we go and we're going to extrude them. And we're just going to go up to, instead of a blind, we'll go up to surface. And we'll pick that right there. And there's our frame for that box. So you can see how quickly we can do that. We can look for clearances. And then from here, we can just add whatever kind of, expanded metal or, fencing we want to add in there. We can add our door in and so forth. So you can see we can very quickly design something that's going to fit. Now, the other thing you could do is you can bring in stuff. Like if you have kind of pre-built safety boxes and things of various sizes, you can build up a whole library of this stuff and bring it in. So for example, here is one. So let's say, this is a shut-off valve or something of importance, and we need to have that boxed in. And let's say this here is just a standard size box. Well, again, I can bring that in, and I've got it here. And, I can just move it into place and make sure, it's going to fit. So let's, slide it over. But you can see we've got that handle there, so we need to bring it down. And, we can take a look. Is this the right size box? Et cetera, and move it into place and look around. Now we're going to have to make an opening for that hose or line, whatever it is. Okay. So we'll make a cutout in that, but you can see, I can look at it and say, okay, that looks good. I could swing the door back and forth here to make sure it works. But let me load in the final design so you can kind of see what everything looks like. Okay, so here is the final design. You can see our box here, and then our smaller box. You can see we added some, we cut a hole in the expanded metal, and then we added in some reinforcement around that hole. We added the fencing on here. We added our hinges and our lock and so forth, and then also we brought in just some commercially available, basically people. And you can see this guy standing inside the fence, so we're going to want to move him a little bit here. So we'll grab this guy here. And, again, we can use this just to check for clearances. So let's say a guy was standing, realistically about right there. And then we can move like we showed earlier. Let's go to a top view. Let's rotate it 90 degrees here, and we could come in here and we can make sure, that we have clearance. Okay. So a lot of this stuff can be built into a library and just loaded in, especially things that are of standard sizes. But, if we need to do some custom stuff, without measuring anything by hand, we can create it and then we can render it up so the customer can look at it. We can check clearances and so forth. And this was done with literally a couple of scans with the Surphaser. We obviously didn't get the back of the machine. It was tight up against the wall. Could we have moved over and tried to get a few back there? Sure, but we didn't need it. So with, I think, 2, maybe 3 scans, we got everything on this machine we needed to design these, safety devices to keep people clear of the machine while it's running, and to, keep access to critical or dangerous parts of the machinery away from people. And then, these solid models that we built can be then broken down into, create drawings or whatever you need to do. But this is all 3D CAD data. Obviously, the scan data is just scan data, but all this CAD stuff here can be exported, taken into a CAD system or a CNC system, whatever it is you need to actually manufacture this stuff, to either bend the piping here, to cut all the pieces, to do all your drawings, whatever you need to do, you now have all this. And then this can be built or be part of a library. So if you ever go to do a machine like this again, and maybe the machine's a little bit longer, slightly different, you could load in this stuff and just make modifications to it to make it fit. All right, so next up, we are going to scan this bandsaw. And for this operation, we're going to use a handheld scanner, specifically the Creaform GoSCAN Spark scanner. Now, the scanner doesn't necessarily require targets, but a lot of times we'll put them on the object just because it makes tracking it easier. And we're using a product called SpeedTarget here, which is clear tape with targets on it. It makes it great for stuff like this where you've got kind of big gaps between the geometry. And then we're also using magnetic targets. Magnetic targets are great because most of this machinery is metal and you can quickly throw them on there. So it's not that you couldn't scan this without targets. It's just going to make it a lot faster because it can track better with having those targets. So it's using a combination of geometry-based alignments and targets to scan this. And it only takes a few minutes to put the targets on. And then we just move around and 3D scan it. Like the Surphaser, most scanners are line of sight. So I always call it digital spray painting. You've got to move around. You want to try to be perpendicular to the surface and try to get as much as you can. And how much data you collect is really going to be determined on, what it is you're trying to design. If you don't really need the whole machine, you don't have to scan the whole machine, but we'll go ahead and do a decent job. So the other thing we're going to want to do is digitally archive this. So if we ever want to do this same machine again for another customer, we already have it. Now, maybe they want something done a little different in terms of the safety equipment, but we can basically build up a library of machines in different configurations that we can use to do different design. So we'll just keep going around on the machine it's here until we get all the data we want. And again, we don't have to scan everything, but if we've taken the time to go ahead and set this up, it probably doesn't hurt to just go ahead and scan the whole thing. And a part like this probably takes you about 15 minutes, maybe 20 minutes to do a decent job to scan it up. And then we just remove the targets and we're done. And then we can take it into the reverse engineering software again and start working on whatever, safety equipment we want to design for this particular machine. Okay, so here we are again in Geomagic Design X, and you can see our scan data of the bandsaw. So we scanned pretty much the whole thing all the way around, all the detail that we needed. And you can see I've also broken up the scan data again into 3 pieces, and that's going to let me rotate and move around some of the key pieces of the machine. Now, what we're wanting to build here for this one is just a guard behind the machine, or a fence, because this thing swings around and it also swings up and down, and we just want to keep people safe that might be walking behind it. And because this is a small shop and we want to maximize our space, instead of building a big kind of square fence around it, what we did was we built this on an arc like you see here. And to make sure we've got good clearance with the bandsaw, we did the same thing as before, where we can come in here, we can transform the scan data. For example, let's say we pick the head here, and we want to use a local coordinate system. And you can see I've got a vector set right here, which is this pivot point right there. I just fit a vector through the scan data. So I can come in here and pick that vector, and then I can rotate this up and down. Let's say we rotate it down to here like that. And then what we're going to do next is the same command, but this time we're going to pick the saw, and we're going to pick the pivot base here, kind of what that the saw head mounts to. And this time we're going to rotate around vector 1. And let's come up here in the top view. And now when we rotate, you can see we're rotating this way. So we want to see the swing of the saw and make sure, you know, whatever our lowest degree angle is, it'll still swing around and not hit the fence behind it. So this is kind of nice. You know, you can certainly do this with CAD data, and it's not a big deal. But to be able to manipulate scan data like this, almost like kind of like an assembly, it's all manual, but it is really nice. We can see how close we want to, you know, create that that fence to the back of the machine. Now, one thing that, you know, really helps when you're doing things digitally is you can go back and review things, obviously. And after I designed this fence, I realized it's not going to work in the position it's in. So you see here, this is a hand crank, and you know that could have been easily missed if I had just taken hand measurements or taken pictures. So I realized that something's got to change. So I've either got to move this main post back, or maybe try to, you know, slide the fence over a little bit, or something, so that, you know, that doesn't collide. So that's, again, one of the beauties of working with things digitally is you can try different things, or if you find mistakes, you can easily go in and correct them. But all we needed for this was a simple fence behind the machine, and we wanted a design that minimized, you know, the space it took up. So that's what we have here. So this is all scan data, and this is all just CAD data, and this was all just sketches, typical just CAD functionality, nothing crazy here. And again, if you have a library of stuff, you can just load it in and kind of assemble it and move it in place and fit it and see how it looks.
So that wraps up the video on designing safety equipment for machinery. Now, if you want to learn more about EMS's ability to go out and do the scanning and modeling for you, or what Elevation DF here in Tampa, Florida could do for you, give us a call at 877-845-2700, or in the description below is a link to a quick form you can fill out, and we'll contact you and talk more about what you're looking to do. Whether it's have us do it, work with Elevation DF, or maybe you want to buy your own equipment and do this yourself. But any way you want to do it, reach out to us, and this wraps up the video on designing safety equipment for machinery.